Section 3.9a. On Blackboard, I have uploaded this same worksheet so that you can download it and follow along. 3.9a, Example 1. Related rates problems compute the rate of change of one quantity in terms of the rate of change to another quantity. The trick is to find an equation, or the relation, that relates the quantities together. Let's look at an example. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 centimeters cubed per second. How fast, this is another rate, fast, is the radius of the balloon increasing when the diameter is 50 centimeters? Let's look at the solution. I always find these three things. In step 1, I find the given, the unknown, and the relation. Number 1, the given. We are given that volume increases at a rate of 100 centimeters per second. The volume increases at this rate. In calculus terms, that's dV, the change in volume with respect to time, is equal to 100 centimeters cubed per second. What's the unknown? How fast is the radius of the balloon increasing? That's what's unknown. How fast is the radius increasing? In calculus terms, that's dr dt, the rate of the radius with respect to time. We don't know that, but we need to know that when the radius is equal to 25 centimeters. We are given diameter in the original problem, and the radius is 1/2 the diameter. Now the relation. In this case, we are talking about a spherical balloon. The equation for the volume of a sphere is volume equals 4/3 pi r cubed. Now, step number 2. We want to differentiate our relation on both sides with respect to time. So the derivative with respect to time of the left-hand side equals the derivative with respect to time on the right-hand side. On the left, that simplifies to dV over dt. dV over dt. On the right, we have 4/3 pi. Then the derivative of r cubed is 3r squared. Then times dr dt, which simplifies dV dt to 4 pi r squared dr dt. Step number 3. Solve for the unknown, then plug in what's given to us. What's unknown is dr dt, so I'm solving this equation for dr dt by dividing 4 pi r squared over to the left-hand side. So dr dt equals 1 over 4 pi r squared times dV dt. We know what r is. That's 25. So I plugged in r equals 25. We know what dV over dt is when r is equal to 25, and that's 100. So that simplifies to 1 over 25 pi, and that's centimeters per second.